Hi, my name is Gorka Sadowski. I'm the CEO and founder of Akalak. Akalak is a consulting firm dedicated to cybersecurity, and we are making the world a safer place.
And I'm Philip Rathle, VP of Products for Neo Technology, the company behind the Neo4j graph database. And we are here to help you make more sense of data.
So today we'll be talking about three very common types of fraud. There's many more, but these are probably more known. Retail banking and first-party fraud, car insurance, and e-commerce. The first two, retail banking and car insurance fraud, are very often carried by fraud rings, and we'll see how these organize. And e-commerce fraud can be organized in rings or can be done by individual people.
And for those of you attending the webinar today, I wanted to call your attention to an article published in the Global Banking and Finance Review just this morning, actually. And it provides a good executive summary of the content that we'll be discussing in this webinar, focusing primarily on the first use case that Gorka mentioned, which is first-party fraud in retail banking. We'll send a link to that after the webinar.
So let's jump into the first one, retail banking and first-party fraud. So what is first-party fraud? First-party fraud is when people, and you notice that people is between quotes, and we'll see later why, is when people open many lines of credit and they have absolutely no intention of paying those debt back. So as you can see in here, somebody opens many accounts and now he's running away with the money. There are two main type of fraud for retail banking. One is third-party fraud and the other one is first-party fraud. The difference is that in third-party fraud, you have usually identity theft taking place. So somebody gets his identity stolen, and that's complete social security, address, phone number, history, date of birth, and all of these information. And he's using that data to go to Macy's and open a credit card at Macy's, or go to a bank, open an account, and get some credit cards. The reason why first-party fraud is a little less known and has significant impact is that with first-party fraud, there's no victim other than the bank. The bank is the only victim in here, and they typically don't want that to be known, and they either downplay the impact of that fraud or they don't report it as such. There are some wild numbers in here, and these are numbers that have been validated by Experian and some other organization, and even the SEC has its work has worked in publishing some of these numbers. But the impact of first-party fraud is in the tens of billions of dollars in the US only. One of the statistics that I think is also very difficult to believe, but that's been validated, is that almost 20% of all unsecured bad debt is actually misclassified, and it's first-party fraud. So under the radar screen, very big problem, and we'll see how this works. Let's talk a little bit about synthetic identities and why that is important. When fraudsters organize their rings, they know very well that the more people in the ring, the more potential for somebody to get caught, go to the police, rat, brag, and them being and the police catching up with them. So what fraudsters like to do is have as small a ring as possible, and through different mechanisms such as synthetic identities, they are able to inflate the number of fake or synthetic identities that they can create in this fraud ring. stolen identity is a true, real identity that's been stolen and replicated somewhere. Fake identity is totally invented pieces of information, and that usually doesn't fly. Banks have mechanism to flag those. But one way for fraudsters to be very effective is by using synthetic identities. So in this example that we see here, there are two people who are sharing their address and their phone number. So as you see in this picture, there are two addresses and two phone numbers. And using these two addresses and two phone numbers, and by the way, these phone numbers are disposable mobile numbers that you can get with disposable SIM card. And what you do with these two addresses and two phone numbers is that you are able to create 4 fake identities. And these people go to banks and they use those synthetic identities to open accounts with the banks and open credit lines with the bank. So new accounts are added to the original one, and they're very smart because those addresses are actually real addresses and those numbers are real numbers. And if the bank sends mail to these addresses, or if the bank calls those phone numbers, well, the fraudsters are there and they are able to answer the phone, and they are able to make sure that the bank thinks that it's a real identity, but it's a synthetic identity. So the accounts are being used normally. They are regular purchases, timely payments. There's a concept known as revolving doors, which is a cash amount is going from a credit card account to credit card account, and gives the impression that all of these are legitimate transaction and legitimate people having a normal behavior in there. In time, the banks increases the revolving credit lines because it's an observed responsible credit behavior, and these fraudsters essentially max out all of these, and one day they will bust out, and it's called busting out, which is they empty all of the credit lines, they max out all the credit card, and then suddenly, poof, they disappear. So what happens is collections process ensues, and it's going to collection, and even sometimes the feds are involved, and they go knock on the door of these addresses, which are the real addresses where the fraudsters live, and the fraudsters, whose name can be Tony and Philip, if you want, they say, hey, I don't know who John Smith is. I have no idea who Frank Vero is. I have no idea who Mike Grad is. I don't know who Vincent Poussin is. And then the bank has to write off the uncollectible debt. So it's a very lethal, very effective way for fraudsters, even small rings, to invent synthetic identities and make some significant impact. So 2 fraudsters can easily rack up bills as high as 80K. That's with 2 people. So imagine really well-organized mafia rings where you have 20, 100 people creating fake identities. We'll see later that that can make a significant impact. So what are the approaches that have been considered best practice in the industry now? And I'm referring to Gartner's layered fraud prevention approach. It's a series of different layers, and there are essentially 2 big buckets in this. The first bucket is analysis on discrete data. And in discrete data, you look at patterns and observe patterns of behaviors, but not necessarily trying to connect each of these individual data points. And what Gartner has seen is that this is often not enough, and the next frontier in catching fraud now is in connected analysis. So looking at these discrete data analysis, the way it works is that you know over time, and you observe over time, and big data technologies are often using this, you observe over time what is called accepted behavior or normal behavior, and you establish patterns of normal behaviors. So for example, in here, the more accounts you have, the higher your revolving debt. And if you have data points that are way above or way below what is considered normal behavior, then you investigate those. You have to know that the cost of investigation is very, very high. Investigation is performed by units called SIU, Special Investigation Units, and those are people who are very qualified and very overworked, because what happens using this discrete data analysis is that you have a lot of false positive and a lot of false negative. Maybe somebody has a high number of accounts and very small revolving debt, and that's a legitimate person. And maybe some people have a lower number of accounts, but those revolving debt is very, very high, and that is also acceptable behavior. So the risk in here when you're using only discrete data analysis is to have false positive, false negative, to antagonize your true legitimate users by having special investigating units go after them. But the advantage is that it's simple and it works with rookie fraudsters. It does not necessarily work with fraud rings, because fraud rings actually know exactly how this discrete analysis is working, and what they do is that they remain under the radar screen. So they don't, they have normal behavior, and looking at it through discrete data, these fraud rings appear as totally legitimate people who have no connection one with the other. However, when you start looking at this through the angle of a connected analysis, then things start making much, much more sense. And as you uncover that actually some of these addresses are shared, that some of these phone numbers are shared, and that some of these patterns of behavior are actually much more meshed than originally thought, then you can be very effective in catching those fraud rings. So a 10% fraud bust out in here usually runs into the millions of dollars. And those are very, very difficult to catch with traditional technologies. And going back to big data and relational databases, you would be doing many, many joins inside huge tables, and that is very, very difficult to do after the fact, and near impossible to do in real time. So that is the limit of traditional legacy technologies, and looking at this problem through the lens of a graph is very effective.
So we're going to go through a short example. A picture is worth 1,000 words, and we're going to get into some dynamic pictures in a moment. So here's an example of the type of pattern that we're looking for in first-party fraud. You have several account holders who happen to share different types of information. I'm actually going to show you this, what this looks like when you're using Neo4j, which is a graph database really designed to be able to understand and navigate these kinds of relationships, not only very easily, but very, very quickly. Neo4j does this type of thing in real time for a number of financial services and other types of companies. And this type of pattern that we're talking about in fraud detection is very much what graph databases are designed to do. So here you can see this image which shows 3 account holders, and now I have shared identities, which are all shown in one color here, sort of this greenish color. And I've got 3 people sharing an address. Well, that's probably not suspicious. But then I have 2 people sharing a phone number. That may or may not be an issue. Maybe less common in these days of people using mobile phones for more and more things. But then I've got 2 people sharing a social security number. That's a bit suspicious. And if you look at each of these people, they each have a number of different types of accounts in gold, in yellow here. And if you add these up, this potentially could add up to a substantial amount of credit exposure if this does indeed prove to be a fraud ring, which if we didn't have the social security number, the probability might be less. With that shared social security number, now all of a sudden this entire ring becomes quite suspicious. Now, what I've been showing you here actually isn't a static image. It's the query response from data that's actually stored in the database. And so here I'm showing the entire pattern, but now let's look at some kinds of questions we can ask. So if you have all of your account information in the database, and getting it in is just simply the question of importing it from whatever systems it currently exists in, dump it into a CSV and then load it into the database. If I want to find accounts with shared details, you run a query. I won't go into this in great length here, but by running it, I can actually return the people in this larger data set that includes more than just what I showed earlier, and find suspected rings. So here I have a ring of size 3, a ring of size 2, another ring of size 2. And you can see this runs quite fast. It runs very fast with even very large data sets. In fact, one of the distinguishing factors of this type of technology as opposed to other types of technologies, some of the other big data, Hadoop-style technologies or relational databases, is that in those, the bigger the data set, the longer these kinds of real-time queries take. That's actually not true with Neo4j because it's a native graph database. The faster, the bigger the data set, the more this type of query actually takes roughly the same amount of time. Now, here's an extension of this. Let's say I want to calculate the fraud risk. Well, I can actually go and prioritize my, say, manual efforts if this gets escalated to someone who's actually going to investigate as a function of what's the potential risk. So here what I've done is I've actually tallied up the total amount of financial risk by adding up all of the credit lines. So very simple example, but this gives you a flavor for how you can actually solve some of the problems that Gorka's been talking about.
Great, thank you. Let's go into a different type of fraud, the insurance fraud and automobile insurance. And there's a few terms that you'll see in quote, and those are terms that are coined either by the insurance industry or by the fraudsters and the mafia themselves. There's something that they jokingly called whiplash for cash. Whiplash for cash is when a fake accident happens and people said, oh, my neck hurts, and you are going to have to pay me a lot of money, and that is called whiplash for cash. Whiplash for cash is something that is very effective because indeed soft tissue injuries are very hard to detect. They can be very painful and very debilitating, and it's very difficult for doctors to really understand if it's a true legitimate pain or if it's something that is invented. So whiplash for cash and paper collisions. Paper collisions are accidents that never happen other than in the insurance papers. So you have fake drivers, fake passengers, fake witnesses. In fact, I saw this past weekend in the Ontario, Canada newspaper that some people got arrested because they were selling seats. And selling seats means that this is a totally staged accident. It's a paper collision. They have everything figured out. They have lawyers in standby. They have doctors in standby. They have fake drivers, fake witnesses, and they can sell you a seat as a passenger in the car, and they guarantee you in the order of minimum $40,000 return, and they sell you the seat for a few $1,000s. So it's called selling the seat. There is another very interesting exercise that the insurance companies did in the 50s in New York. What they did is they got a bus, a transit bus from New York, and they had the bus full of insurance investigating units, people who were working for the insurance, and they staged a fake accident. And lo and behold, within a few days, so there were 30 insurance agents in the bus. Within a few days, they had 70 claims from people who claimed to have been hit by the bus, were in the bus, and somehow wanted to get cash from this accident, which was a totally invented, staged accident. So people are fast to jump into this Whiplash for cash scheme. And I put in here a few of these. Those are known tricks that people use. Maybe the one that I think the side swipe in the bottom right is one that involves fake witnesses. And when you have these type of behaviors from cars, then a fake witness will show up out of the blue and say, well, it's the fault of this guy. It's actually totally fabricated. But if you have 3 fake witnesses against your word, you are in trouble in here. So there's a lot of these. And how bad is it? Well, it's actually really bad. There has been some studies in the US, and the worst state for Whiplash for cash is actually Florida, with Miami and Tampa being 2 of the cities in the US with the worst Whiplash for cash. That is due to local laws in Florida with what's called the PIP, which is the uninsured motorist protection. And what happens very often in Florida is that there is a paper collision, and you say somebody hit me and run away. And because you have uninsured motorist protection, then this hit and run gets paid systematically by the insurance. So the National Insurance Crime Bureau says that auto insurance fraud and paper collision and Whiplash for cash is responsible for adding $200 to $300 a year to your individual insurance premium. So if you think your car insurance is too high, and it may be, that is often due to these type of frauds. In this example, we see that several people, so in this case 6 people working together, can create 3 fake accidents. Keep in mind again that these participants are not necessarily true people, but they can be synthetic identities. Fake witnesses, fake drivers, fake passengers, but real money. So in this case, you have people, and again, as we were saying earlier, you want to have a tightly knit fraud ring, and you actually recycle. They call that recycling the roles. So in one accident, somebody is going to be a driver. In the next accident, he's going to be a passenger. in the following accident he's going to be a witness. You want to avoid somebody getting 20 or 100 accidents during the year, because that would be very suspicious for the insurance. So those people recycle the roles, and they are able to create a lot of fake accidents. 6 people, and this can be 2 people with creating 6 fake identities, you're getting hit with a 400K total exposure in here for the insurance. Again, the traditional approaches, as we saw earlier, discrete data, connected data, and these fraudsters are very, very smart. In each Whiplash for cash, they're not going to ask for $1 million. They're going to ask for 50,000 or 80,000 or 100,000, and they remain within the bounds of what is accepted as far as a claim for each of these accidents. It becomes more and more efficient for the fraudster from these fraudsters to work together and have more accidents. In here, you have 10 fake identities, and the impact is in the millions of dollars for insurance. And the more efficient the fraud is, you would think that the easier it is to catch, but in fact, because those guys are recycling identities, and because now you are dealing with very large data sets, with using traditional technologies of big data analysis, it becomes more and more complex, and the more the ring grows, the more complex the data analysis becomes. So as we saw earlier, this is an example of how we could model insurance fraud as a graph. You have cars, people involved, and creating accidents. And there are relationships, so people can either be driving, or they can be passengers, or they can be witnesses. People can be adjusters, they can be doctors. And by using this connected view of looking at accidents as a graph, you can immediately see if people are being recycled, and if people are being drivers and witnesses and passengers. The likelihood of somebody in a year being 3 times the driver, 5 times the witness, and 10 times the passenger in accidents is cause for concern, and you can send the special investigation unit to validate these accidents. In here, we can jump, and I'll go pretty quickly in here, because I hope you get the point that when you are doing an e-commerce fraud and you're doing online payment fraud, you have a certain number of IP addresses, and a transaction is coming from a particular IP address using a particular credit card number, using a particular ID, so user ID password, and using a specific delivery address. And these are usually pretty well balanced, and they can be the cases where you have a big house with several people living there and sharing one or more credit card, and having a specific delivery address. But as you start having a very meshed network in here, and as you start having a very connected subset in your online payment graph, it is really cause for concern. And if I was looking at this graph, I would say that there is probably some fraud originating from IP address IP1, and I would definitely validate and be very suspicious of all these transactions in here on the left-hand side. So we talked a little bit about retail banking fraud and synthetic identities. We talked about paper collisions and Whiplash for cash. We saw that a lot of these are carried by fraud rings, that traditional technologies, and even analysts are saying that legacy technologies and discrete data analysis is maybe not enough. We saw that graph is a very powerful way of looking at this and doing connected analysis.